Alright, in this video here, I'm going to talk about the unit circle, just all the stuff you need to know about the unit circle, and like little patterns, little tricks you can use to remember all the things you need to know about the unit circle. A lot of people see this and say, well, there's a whole ton of numbers and things that I need to memorize here, but if you see some little patterns to it, it's really not so much to memorize. So the first part I have up here, I didn't put up the terminal points yet, which is the coordinates of each point along the circle. I'll talk about that in a few minutes. But the first thing I have up here are what we call the t values. Remember, the t values represent the distance we're moving along the circumference of the circle, and we always start on that positive x-axis, right? So the 0 here, if I start on the positive x-axis and I don't move at all, if I move a distance of 0, well then I end up right there on the positive x-axis, right? Remember, the full circumference of the unit circle is 2 pi. Right, so if I go all the way around the circle and end up at that same starting point, I've gone a distance of 2 pi. Right, if I go halfway around the circle, well, half of 2 pi is 1 pi, so halfway around the circle is pi. Right, if I do half of that, a quarter of the circle, well, half of pi is pi over 2. Right, remember these fractions you can think of as fractions of pi. So like pi over 2 is like 1/2 pi. Right, so then in the first quadrant here, we have pi over 6, which is 1/6 of pi. Right, if I go this distance 6 times, so 1, 2, 3, 4, 5, 6, I end up at pi. Right, so that's 1/6 of pi. Pi over 4 is 1/4 of pi. Right, pi over 4 is halfway through that first quadrant. Right, half of a half is a fourth. Right, and if I do that 4 times, 1, 2, 3, 4, I end up at pi. Right, pi over 3. That's 1/3 of pi. If I go that distance 3 times, so 1, 2, 3, I end up at pi. And then, like we said, pi over 2, that's half of pi. Right, so for that first quadrant, you just need to remember what those are. It's pi over 6, 4, 3, 2. Right, it's always, in that first quadrant, it's just pi over a number, and it just counts down 6, 4, 3, 2. We skip over the 5. I mean, there is a pi over 5. It's going to be in here somewhere between pi over 6 and pi over 4, but that's not one of the key points that we need to know on the unit circle, right? It does exist, it's just not one of the ones we need to be aware of. All right, so you go 6, 4, 3, 2, right? It counts down. And if you remember it as a fraction of pi, and pi is halfway around the circle, it becomes easier to remember. Well, 1/6 of pi, that's the smallest fraction, so that's the first one I get to. 1/4 of pi is the next smallest fraction, and 1/3, and then 1/2 of pi. You can kind of figure them out from there. All right, so those are the ones in the first quadrant. If you know the ones in the first quadrant, like which one is which, there's a way then to figure out all the other quadrants without actually having to memorize every single one of those other numbers, because that's a lot of stuff to memorize. And I would advise not trying to do that. See the patterns to it. All right, so here's a couple of the patterns, right? So there's several that you kind of put together to fill in the whole unit circle. All right, so notice all the points that are closest to the y-axis, not the ones on the y-axis, right? The ones on the y-axis are the pi over 2s, right? 1 pi over 2 up here, 3 pi over 2 down there. All right, so the ones on the y-axis are the pi over 2s. The ones on the x-axis are the pi numbers, right? Pi, 2 pi. The ones that are closest to the y-axis, over here and over here, notice those both involve a pi over 3. And the ones down here that are closest to the y-axis also involve the pi over 3s. Right, so if you remember the first quadrant, that the pi over 3 is the one that's closest to the y-axis, the next one on the other side of the y-axis is also going to be a pi over 3, and the ones on either side of the y-axis down here are also those pi over 3 numbers. Right, so the ones over 3 are the ones that are closest to the y-axis. Right, the ones that are closest to the x-axis are all the pi over 6 numbers. Right, the first one over here that's closest to the x-axis is pi over 6. The one over here on this side that's closest to the x-axis is another pi over 6. Right, down here, in the third quadrant, the one that's closest to the x-axis, pi over 6. In the fourth quadrant, the point that's closest to the x-axis is pi over 6. Right, so all the points here, the 4 that are closest to the x-axis in each quadrant are the pi over 6 numbers. Right, and then the ones in the middle of each quadrant are the ones that involve a pi over 4. Right, the one in the middle, this is a pi over 4, over 4, over 4, over 4. Right, so it's consistent with each quadrant. All right, so for each quadrant that you get to, each quadrant has 3 points within the quadrant. Right, the point closest to the x-axis is your pi over 6 number. The one closest to the y-axis is your pi over 3 number. The one in the middle is always going to be your pi over 4 number. Right, so if you can get that straight, then you know the denominators of all your fractions all the way around. You can just even, like if you want to fill in an entire unit circle, just take all the points close to the x-axis, write a pi over 6 on all those points. Take the ones in the middle, each one is a pi over 4. Take the ones closest to the y-axis, each one is a pi over 3. The ones on the y-axis are the pi over 2s. All right, so if you get that down, you've got all your denominators, but now, all the numerators, though, are completely different numbers. So how do we figure out what all those numerators are going to be? All right, there's a pattern for that as well. All right, for the numerators, well, the first quadrant is easy. The numerator for everything in the first quadrant is 1 pi. All right, so it's 1 pi over 6, 1 pi, so just pi over whatever that denominator number is. In the second quadrant, the numerator is 1 less than the number in the numerator is 1 less than the denominator, right? They all involve a pi, right? But the number in the numerator that's with the pi is 1 less than the denominator. All right, so if I know up here in the second quadrant, the point that's closest to the y-axis is going to be a pi over 3, the numerator is 1 less than 3, it's 2 pi over 3, right? This one is 3 pi over 4, 5 pi over 6, right? Even this one up here is 1 pi over 2, and 1 is 1 less than 2, right? So, right, for each one of these, in the second quadrant, the numerator is 1 less than the denominator. All right, so if you know where the denominators are, like we just talked about a couple minutes ago, second quadrant, first quadrant numerator is 1 pi. Second quadrant, it's 1 less than the denominator, right? 2 over 3, 3 over 4, 5 over 6. In the third quadrant, the numerator is 1 more than the denominator. So 7 pi over 6, right? 7 is 1 more than 6. 5 pi over 4. 5 is 1 more than 4. 4 pi over 3. 4 is 1 more than 3. All right, so again, the denominators follow the patterns that we saw before. And then the numerators, it's 1 pi, 1 less than the denominator, 1 more than the denominator. The tricky one is the fourth quadrant. The fourth quadrant, the numerator is 1 less than twice the denominator. All right, so what I mean by that is my denominator is 3. 3 times 2 is 6. 1 less than 6 is 5. So it's 5 pi over 6, right? Because 6 pi over 3, that's equal to 2 pi, right? So the ones here are one fraction less than 2 pi, right? So if I multiply the denominator by 2 and then subtract 1 from it, I get the numerator for my fourth quadrant, right? 4 times 2 is 8. 8 minus 1 gives me 7 pi over 4, right? For the sixth one, 6 times 2 is 12. 12 minus 1 is 11 pi over 6. All right, so that's the pattern where you can figure out what your numbers are, your t-values, which again refer to the distance that you're traveling along the circumference of the unit circle. All right, so denominators, close to the x-axis, you have a denominator of 6. Close to the y-axis, you have a denominator of 3. The ones in the middle of each quadrant have a denominator of 4. They all have a pi in the numerator. First quadrant, each one is a 1 pi. Second quadrant, the numerator number is 1 less than the denominator. Third quadrant, the numerator is 1 more than the denominator. The fourth quadrant, the numerator is 1 less than 2 times the denominator. All right, so if you get those patterns down, you don't have to memorize all these numbers around the unit circle. You can just know those patterns, and you can fill in that unit circle pretty quickly without having to like I said, memorize all that stuff. All right, so that's the t-values, just the distances around the unit circle. I'm going to pause the recording here, and I'm going to put up the terminal points, the actual coordinates, the x and y coordinates for each point around here, and then I'll talk about how to figure out what those are for each of the points that we have on here, right? Because there's patterns for those as well. All right, so I put up here now on our unit circle, I added the terminal points, so the x and y coordinates for each one of those points that we had on there a minute ago, right? So it looks like a whole bunch of information. Like now I've added all those points. You're like, wow, this is like so much more stuff than just what was on here before. But once again, if you know a little bit of it, you can then extend that to the rest of it and use like the symmetries of the unit circle to figure out the terminal points for any of the rest of it. And the part you need to know is just the first quadrant. Right? If you know the terminal points for the first quadrant, notice it's all the same numbers. They're all 1/2 or root 3 over 2 or root 2 over 2s or 1s or 0s, right? So they're all those same numbers. It's just when you move to different quadrants, some of those coordinates get negative, right? So if you know what's in the first quadrant, all you do is like just reflect those points, reflect the x and y coordinates down, and if you go from the first quadrant to the fourth quadrant, you make the y negative. If you go from the first quadrant to the second quadrant, you make the x negative. If you go from first quadrant to the third quadrant, you make both of the x and y negative, right? But it's the same numbers as what you have over here. And the numbers stay with the denominators of the red numbers that are in here, the pi numbers. Right? So And there's a trick to knowing what's in that first quadrant, and it's what we call the trig hand. Right, now I did another video where I explained trig hand, but I'm going to explain it again here, just in case you missed that video or didn't understand it the first time I said it. Your left hand with your palm facing to you, right, so you're looking at your palm right there. Your left hand represents that first quadrant. The pinky is the x-axis, the thumb is the y-axis. And the 3 in the middle are the pi over 6, the pi over 4, and the pi over 3, right? So when I want to find the terminal point for one of those points in the first quadrant, I put down the finger that corresponds to that number, right? So if I want to find pi over 6 is my ring finger, I put that finger down. The number of fingers above that gives me the x-coordinate. It's the square root of 3, and I always have a 2 in my palm, so it's the square root of 3 over 2. That's my x-coordinate. The number of fingers below the one I put down is my y-coordinate, so it's the square root of 1 over 2, but the square root of 1 is 1, so that simplifies to just be 1/2. Right, so I identify which number I want. It's pi over 6, pi over 4, pi over 3. Now when I put down my finger for pi over 3, the number of fingers left standing above that gives me my x. So for pi over 3, my x is 1/2, and my y is the square root of 3, because I have 3 fingers below. That gives me my y-coordinate, square root of 3 over 2. Right, for the pi over 4, that's my middle finger, right? That's the one in the middle of that quadrant. It's the square root of 2 over 2 for my x, and the square root of 2 over 2 for my y. Right, so I put down whatever finger I need, and then I count. The number of fingers standing above gives me the x. The number of fingers below gives me my y. Right, so that's a real easy way to not even memorize, but just to know what those terminal points in that first quadrant are going to be. And it even works for the pi over 2. Like for pi over 2, if I put down my thumb, well, there's 0 fingers standing above that, so my x-coordinate is 0. And below that, I have 4 fingers, so it's the square root of 4 over 2. But the square root of 4 is 2, and 2 over 2 equals 1. Right? So it even works for that point. And for the 0, if I put down my pinky, which my fingers are not quite flexible enough for me to do that without using my other hand, but I have 4 fingers above that, so that's the square root of 4 over 2, which is 2 over 2, which equals 1 for my x-coordinate. Below it, I have nothing, so my y-coordinate is 0. All right, so pretty simple trig hand. Whatever one of those angles you want, for pi over 4, you put down your finger. The number of fingers above is your x. The number of fingers below is your y. And it's always the square root of that number over 2. All right, so that's how we can get those terminal points in the first quadrant. And then to get terminal points that are in any of these other quadrants, well, it's the same numbers. I just have to change the signs, the positives to sometimes change to negatives. And notice, all the pi over 3 numbers, the ones that are closest to the y-axis, right, all of those involve 1/2 comma root 3 over 2, right? For 2 pi over 3 here, it's negative 1/2 comma root 3 over 2, because when I move that point over to the second quadrant, my x-coordinate becomes negative, but my y is still positive. Right? If I move that point down to the third quadrant, 4 pi over 3, well, that's negative 1/2 negative root 3 over 2, right? It has the same numbers as the pi over 3 in the first quadrant, but in the third quadrant, both my x and y are going to be negative coordinates, right? Because it's negative x and a negative y. So I just take the numbers from the first quadrant and make those two negative for the 4 pi over 3 in the third quadrant. And for the fourth quadrant, the 5 pi over 3, if I take this pi over 3 and reflect it down, again, the same numbers, 1/2 and root 3 over 2, but when I'm in the fourth quadrant, I have a positive x and a negative y. So it's positive 1/2, negative root 3 over 2, right? And it's the same for all the other ones, right? All the pi over 4 numbers, all the ones that are in the middle of each quadrant, are the root 2 over 2, root 2 over 2, right? Notice, all of them with the pi over 4s involve the root 2 over 2s, and then just depending on which quadrant you're in, second quadrant, x is negative, right? So you can even put like a little pattern up here, right? This is negative comma positive. X is negative, y is positive. In the third quadrant, it's negative comma negative. Both the x and y are negative. In the fourth quadrant, it's positive comma negative, right? The x is positive, the y is negative when you're in the fourth quadrant. And then you just take, so if I have, 11 pi over 6, well, I know it's a pi over 6 number, so it's close to the x-axis. 11 pi over 6 is just less than 2 pi, so it's in the fourth quadrant. I know this point here, but if I'm in the fourth quadrant, I need to make the y negative, so it's root 3 over 2 comma negative 1/2. Right, so if you get those patterns of how to do the unit circle, you don't have to memorize the whole thing. There's just a couple things to memorize. Use your trig hand to get the points in the first quadrant, and then you can just reflect them over. All the pi over 6 numbers share the same, all the pi over 4 share the same, all the pi over 3 share the same numbers, just switching the positive and negative signs. and then you use that with what we talked about before for the numerators and denominators, and you got the whole unit circle, only really memorizing a small bit of it.